Interest rates occur in many scenarios. The most common is when you take out a loan or when you invest your money. There are two main types of interest, simple and compound interest. Let's start with simple interest. Say you borrow $1,000 from the bank for 3 months, and they want to charge you 1% simple interest. The easiest way to do that is take 1,000, multiply it by 1%, and then you get $10. So each month you owe the bank $10, and after 3 months you owe the bank $30, or $10 a month. And that's on top of the money that you borrowed. So at the end of the day, you owe $1,000 plus $30, which is $1,030. That is the most basic definition of simple interest. But most commonly, you're going to be using compound interest in the real world. For example, you are taking out a loan for $10,000. The bank will charge you interest on your money in exchange for lending the money to you. But every month that you don't pay, the interest you owe gets added to the total, and then the interest is charged on top of that, and the amount you owe increases exponentially. This interest rate is usually stated as a percentage, followed by the word APR, meaning annual percentage rate, and a stated compounding period, monthly, annually, biweekly, etc. These compounding periods are the set dates when the bank will look at how much money you have borrowed and charge you interest at the stated annual rate on the money that you owe. However, APR is not always correct. For example, if you have an interest rate of 12% APR, compounded monthly, the bank is saying that if you divide the rate of 12% by 12 months, your monthly interest rate is 1% per month. So each month you will owe $100 on the $10,000 loan. If you fail to pay it off that month, the sum, $10,100, will be the amount that you get charged interest on next month. To figure out what you would owe at the end of the year without paying the loan, you have to use a special formula to get what is called the effective annual rate, or EAR for short. The difference between the effective annual rate and the annual percentage rate is that the effective annual rate will tell you what 1% per month compounded will equal at the end of the year. So the formula is EAR equals 1 plus APR over 12 to the power of 12 minus 1. And this is basically just an extension of the simple interest compounding formula, except now the power is to 12 instead of previously being 1. And we'll see that the actual rate that we pay on the money that we borrowed is 12.68%. If you were to compound 1% per month and pay nothing, at the end of the year, you would owe $1,268 on your loan rather than $1,200 if it was a simple interest loan. And that's on top of the $10,000 that you borrowed. This formula can be applied to find the effective annual rate for any rate and any period of time. And the way you would do that is take effective annual rate equal to 1 plus APR divided by the compounding periods that are stated to the power of the compounding period that you're looking for subtracted by 1. Most of the time, using the number that the bank gives you is a good ballpark estimation. As a final, more complex answer, say you have a loan for $14,000 with a 4.5% APR compounded semi-annually, with monthly payments due. We want to know what the effective monthly rate is, or EMR. In this case, EMR equals 1 plus APR over 2 to the power of 1 over 6. So since it's compounded semi-annually, we want to take our APR and divide it by 2, and to the power of 1 over 6 to reduce our number, to lower our number to a monthly rate. So once we do that, we can see that our monthly rate is 0.37%, which is $51.80 of interest per month. You can do similar calculations for effective semi-annual rate, effective quarterly rate, depending on the application you need it for. Many stock dividends are paid in a quarterly rate, but you are usually quoted the annual rate. So you can do the calculations to find out the effective quarterly rate and the amount of dividend that the company will actually pay you on that date.